Hi guys, so welcome to my channel. So today we'll be solving Leetcode 2064, minimized maximum of products distributed to any store. This is a medium level question and it has been asked in companies like Google, Amazon, Bloomberg, Microsoft and Siemens. So let's read through the problem statement. You are given an integer n indicating there are n specialty retail stores. There are m product types of varying amounts which are given as zero indexed integer array quantities, where quantities of I represents the number of products of the ith product type. Now, now we read through the early part of the problem statement. So it says that we have an array that is a quantities array and there will be product types. Okay. So if for example, if you consider the first example, there are two types of products. One product has 11 quantity, other product has 6 quantity. So we'll consider zeroth product and first product. Zeroth product has 11 quantity and first product has 6 quantity, and you have been given 6 retail stores. Now you have to distribute these products among these 6 retail stores. So there is a condition for it. You need to distribute all products to the retail stores following these rules. A retail store can only be given at most one product type. So for example, if there are 6 now, first retail store can only have a product type of 0 or 1. It cannot have both. So this is the first condition. And after distribution, each store will have been given some number of products. So after distribution, with this with considering the first condition, if we distribute all the products among the 6 retail stores, we need to minimize the maximum number of products that are given to any store. Okay, so we need to minimize that, so as much as possible. So let's write down. I have written down the quantities array and the number of stores. So consider there are 6 stores. Now there are 6 stores, right? 1 2 3 4 5 6. Okay, so now I need to distribute my 0th product, that is 11, among these stores, and also the first product, that is 6. So say I distributed 11 here, and since 0th product is finished now, 6 that is the first product I want to distribute among this. So I would distribute something like this and 2. So totally I have distributed, or else there can be multiple other ways, right? I can distribute say 5 I can distribute here, 5 I'll distribute here, 1 I'll distribute here. So I have finished with the 0th product. Now I'll distribute my other product, that is 2 2 2. So if you see in this, what is the maximum that we are given to any retail store? That is 5. So we want to reduce this as much as possible. If you saw the earlier way that I had written, there I had written as 11 here and 1 1 1 1 and 2. So here maximum becomes 11. So now I want to reduce this 11, that is 11 maximum number of quantity of product that is given to an each store. I want to reduce it as much as possible. How would I reduce it? So maximum, what can I give? A retail store can get maximum of one product, right? So now I have been given in this array which is the maximum number, that is the 11. Okay, so if you see, maximum an retail store can get is 11 from here. And what is the minimum that we can get? Minimum is 1, right? Minimum is 1. Now we have got the range, that is max is 11 and min is 1. Now let's run through this. So say if I try to give 11, I tried giving 11, and I tried giving distributing among other that is the first product among this product among rest of the retail stores. So I had to distribute like this, but the maximum was 11. I can still do better. How better? I'll try with 10. Okay, let me erase this thing. Okay, sorry. Okay, I'll try to give 10 to this one and 1. Now I am finished with the first product, that is 0th product. I am calling this as 0th product, that is 0th product. And rest I'll share something like this. I'll share like this. I'll give. So I can give maximum that I have reduced now from 11 to 10. Right, I have reduced my maximum a retail store can get is 10. Now let me try with uh, 9. Okay, okay, 1 second. Okay, now I'll try giving 9 to this one, and remaining is 1 or 2, 1 or 1, 1 or 1, or either I can give 2 as well. I'll distribute rest, that is 2 1 1. I'll keep like this. Now the maximum reduces to 9, and so on. So we have to find as much as possible. Okay, and whenever you listen, whenever you see a problem where they say that you need to minimize the maximum or maximize the minimum, this is a pure case of binary search. Now we have a range. We have a range with us, that is let me rub this as well. Okay, so we have a range, that is 1 to 11. In this example we have a range. Now we want to do a binary search on this. What is binary search? I'll do a left plus right divided by 2. This is my mid, right? So in this case 11 plus 1 divided by 2, that becomes 6. So if I am at 6, okay, let me try with 6 now. So maximum retail store that can get is 6. So let me try doing this. 6 if I give here, okay, what is remaining? 11 minus 6 if I give, okay, if I give 6 to any of the retail store, what is remaining? 5. I'll distribute among these two, okay, something like this and this, I don't care. Okay, now I have 6 as my another maximum. Okay, another quantity of product. Okay, now I'll distribute this like this. So now I can get 6 as my maximum product, and product store can get. Okay, I still I can distribute it properly. I want to see if there is something else, something lower than 6, something lower than this. So if I have to find something lower than this, my this is consider this as low, this as high. Okay, now I'll move my high to mid minus 1, that is 6 minus 1, that becomes 5. Now let me erase this one. Okay, now my high becomes 5 and low becomes 1. 1 plus 5 divided by 2, so the answer would be 3. Now let's try with 3. Okay, let's try with 3. So 3 is, if I distribute 3 for the first product, I am considering the 0th product. Okay, I am consider 0th product. If I remove 3 from 11, it remains with 8. Now I'll again, maximum that I can give is 3. Again I'll give to the second store as 3. Again I'll give 3. And how much is it? Now it is 9. Now I am remaining with 2. So since each retail store can get only one type of product, I'll give the remaining amount. Now 6. I have 6. Okay, now I have 6. Now for this 6, I want to distribute. How much is the maximum that I can give? 3, right? Yes, I can give as maximum is 3, and the remaining 6 minus 3 would be 3. Remainder I'll give. So here the maximum is 3. Can I go bit lower than this? Let us try. Okay, let me erase through this again. Okay, now let me try with 2. Now mid was 3. I'll move my mid. Oh, move my high. High would be something I still want to try, right? Mid minus 1. So that is 3 minus 1. That is 2, right? Now my high becomes 2. So now my new mid is, let me clear this thing. My new mid is 1 plus 2 divided by 2. That is 3 by 2. That will be coming as 1. So my mid is pointing as 1. Can I give 1 so that I distribute all of my products to everyone? Is it possible? Is it possible? 1 if I give here, 1 if I give here, 1 1 1 1, I'm still left, right? I have not given complete zeroth product to every like I have not finished this, right? I have not completed this, as well as this first product as well. So I want to distribute whole products. So I can't do this, right? I need to move my low to the other bound. I need to move my low. This was my mid. Now what happens is mid, now low becomes mid plus 1. Okay, mid plus 1. Let me write it correctly. So low becomes mid plus 1. That is 1 plus 1. So mid, now mid, so sorry, now low and high are pointing at the same point, right? They are pointing at the same point. Now what happens? Now look at this. Now my new mid would be 2 plus 2 divided by 2. That is 2. It is pointing at 2. Now let's see whether we can give whether we can give the 2 or not. Okay, let's see whether we can give this or not. I cannot give now. Okay, so now 2. If I give 2 2 2 maximum 2, how much have I given? I have given 2 2 4 4 6 8 10 12. How much do I have? 17 quantities, but I have only given 12. So I have not completed my 17 quantity. So that is not fulfilling. So still 2 cannot happen. Now my range was 2 was my range, right? Now I cannot do, I need to increase. Now low I have to increase. That is mid plus 1. That is 2 plus 1. Now low is greater than high, which fails our while condition. So we are left. So the maximum, minimized maximum would be 3. We found out that minimized. So our answer is 3. So we are left with 3. So this is a basic binary search. Now let's write a pseudo code for this one. Okay, let's write a pseudo code. So say I have public int minimized maximum. So I have been given an integer quantity and integer as n, right? Integer as n. Now what happens is I need my range, that is low would be 1 and int high would be whatever max of my quantities array. Okay, now while low is less than or equal to high, mid We'll calculate mid, low plus high divided by 2. We have calculated this. Now with this, can we distribute with this mid value with these quantities? Okay, let's see this. Okay, it should be less than n, less than or equal to n. So if it is less than or equal to, we can still do better, right? I need to reduce my high value. Or else what I want to do is, I want to increase my low. That is, I want to move on the right side. If it was inside n, I would have reduced my high, or else I need to increase my low. Okay, and then finally I'll return my low. Okay, you'll see why low is the problem there. Low is the answer there. Sorry, low is the answer there. Okay, so let's write the can distribute method as well. This will return me an integer. Can distribute. Actually, this should have been. Let me rename it properly. So this can be bool as well. So sorry for that. Okay, integer. This is the maximum quantity. Integer array quantities, and retail stores. Okay, so we'll create a count is equals to 0. Now I'll run through the array, that is, I'll run through the complete array, quantities array. And then I'll see, okay, I want to increment my count such a way that I have to do a math dot ceiling of, what is it, q divided by the maximum quantity, because of the space I'll reduce this. Okay, max quantity now, and then return count is less than or equal to of retail store. So I'll explain this code now, this piece of code. With 11, what happens is 11 divided by maximum quantity, say we have 3 now. So 11 divided by 3 gives me 3 dot decimal something. So if I do a ceiling, it covers 4 retail store. If I use 3 as max quantity, I can cover 4 retail stores. I'll add that into my count integer value. And then the next quantity is 6. 6 divided by 3 is 2. Now I'll add 2. So 4 plus 2 is 6. So total retail stores are 6. Total retail stores are 6. So it is still within that retail store count, right? So that is the point here. So this was the pseudo code. Let's go to the real code. I've already submitted that code, so let's just bring back that code. One second. Let's just bring back that code. This is the code. This is in C#, basically. You can write it in your own language, Java, C++. Okay, I have done the same thing. I have written left, then right I have calculated from the max of the array. I've got it. From then I'll loop left is less than or equal to right. I calculate the mid and I check can divide or not. Can it divide? Here in this case, if you see, where was that? Sorry. How do I undo, man? Okay, something happened. Okay, let me load it again, sorry for that. Okay, can divide method I have written. I have given n and nums as the array. Now if I have to calculate count plus is equal to math dot ceiling x divided by double of n and return the count. So if the count that can divide returns is within that retail store, that means I need to reduce my right that is high. And if it is going beyond, so if it is going beyond, like we tried with that example where we gave maximum of one quantity, it will give like 17 store it has to cover, right? Total was 17 in this first case, it has to cover 17. We don't have those many stores, so we need to increase our left bound. So like that, finally we'll get the answer as left. I'll try to submit this. If you submit this, so it runs with 85% and 57% of memory. So that's it for today. Thank you for watching till here. If you like the video, please like and subscribe. Thank you.